All right, so section 10.5, we're going to talk about inverses of matrices and matrix equations. And so when we talk about inverse matrices, we're talking about multiplication. We're not talking about subtraction, but we'll get into that as we go along. So first, let's talk about a square matrix. Square matrix is just exactly what it says, or it seems to indicate is that it has the same number of rows and columns. So these are all square matrices, 2 rows and 2 columns, 3 rows, 3 columns, and so on. And then the main diagonal is just the, starting at the top left and moving diagonally down the matrix down to the bottom right. So we have what's called the identity matrix. And this is a square matrix of whatever size. And this is where each entry on the main diagonal is a 1, and then all the other entries that are not on the main diagonal are 0. So these are all identity matrices, and the subscript just indicates the size. So 2 by 2, 3 by 3, I4 would be a 4 by 4, and so on. And so what the identity matrix uh, represents, it basically, so kind of like there is an identity, a multiplicative identity with the real numbers, and that it is 1, because if you multiply any number times 1, you get the same number back. So 5 times 1 is 1, 6 times 1 is, sorry, 5 times 1 is 5, 6 times 1 is 6, and so on. Same thing with the identity matrix. If you multiply any matrix by the identity matrix, you just get that matrix back. And so that's why it's called the identity. So let's just see how this works. If you see any of these, you can work these out if you want, but if you see any matrix multiplied by the identity matrix, then the answer is just going to be this matrix here. But we'll show this. So we have, if you remember from the last section where we were multiplying, we multiply to get well, let's first get the size. So we have a 2 by 2 here. We have a 2 by 3 here. So we can only multiply if these middle numbers match, and they do. And then the answer is going to be a 2 by 3 matrix, which is the outside numbers. And so we're going to end up with a 2 by 3 matrix. To get this first entry, we multiply the first row of this one by the first column of this one. So we have 1 times 3 plus 0 times -1. And then to get the first row, second column, we multiply the first row of the first matrix by the second column of the second matrix. So this would be 1 times 5 plus 0 times 2. And then to get the next one, first row times the third column. So 1 times 6 plus 0 times 7. And then to get the next row, we'll do this second row of the first matrix times each column. So we have 0 times 3 plus 1 times -1. We have 0 times 5 plus 1 times 2. And then we have 0 times 6 plus 1 times 7. And so when we simplify these, we have 3 plus 0, so that'll give us 3. We have 5 plus 0, so that gives us 5. 6 plus 0 gives us a 6. 0 minus 1 gives us a -1, and then 0 plus 2, and then 0 plus 7. And so you can see we end up, this matrix here, which is the answer, is the same as that one there. And that's what happens anytime you identify or multiply by the identity matrix. And so we can do this, and now this time the identity matrix is on the right side, but it doesn't matter. It doesn't matter which side it's on. So this one is A, and then we'll do B down here. So again, we have a 3 by 3 here. We have a 3 by 3 here. The inside numbers match, and so the answer will be the rows from the first matrix and then the columns from the second matrix. So that'd be a 3 by 3. And of course, we'll see, we'll end up with this matrix as the answer, but we'll work it out just so we can prove it to ourselves. So -1 times 1 plus 7 times 0 plus 2 times 0. And then -1 times 0 plus 7 times 1 plus 2 times 0. So first row, second column. First row, third column, we have -1 times 0 plus 7 times 0 plus 2 times 1. And then second row, we have 12 times 1 plus 1 times 0 plus 3 times 0. Then second row, second column, 12 times 0 plus 1 times 1 plus 3 times 0. And then second row, third column, 12 times 0 plus 1 times 0 plus 3 times 1. And then for the third row, we'll just write these real quick. So we should kind of see the pattern by now. And then the next one. And the next one. Oops, 0, 0 times 0, and then 7 times 1. And then we simplify these, and we end up with the matrix that we started with. So we have -1, 7, 2, 12, 1, 3, -2, 0, 7. So I don't remember if any on the homework have you work through this, but if they do, I mean, you're welcome to kind of work it out to prove to yourself that it does work this way. But multiplying by the identity matrix is essentially the same as multiplying just a number by 1. Does the same thing. All right, so now we can talk about the inverse of a matrix. And so the inverse of a square matrix, and square matrices are the only matrices that have inverses. So if A is a square matrix, then there exists, if there exists an n by n matrix A inverse with the property that A times that inverse matrix or reversed would equal the identity matrix, then we say that this matrix is the inverse. So we're going to verify that B is the inverse of A. So we're going to multiply A times B, and then we'll also multiply B times A. Although if one way works, the other way will also work. All right, so we have first row times the first column, so 2 times 3 plus 1 times -5, and then 2 times -1 plus 1 times 2, and then 5 times 3 plus 3 times -5, and then 5 times -1 plus 3 times 2. Then we should get the identity matrix, the 2 by 2 identity. So 6 minus 5 is 1, -2 plus 2 is 0, 15 minus 15 is 0, and then -5 plus 6 is 1. So we do get the inverse, or the identity matrix, which proves at least halfway that these are inverse of each other. But let's do the other way. So B times A. So 3, -1, -5, 2. And then 2, 1, 5, 3. So we have 3 times 2 minus 1 times 5. And notice this entry, at least in the beginning, is not the same as this. The 2 and the 3 are the same, but the 1 and the -5 are not. So we're not multiplying the same numbers, but we're going to end up with the same thing. So then we have 3 times 1 minus 1 times 3. We have -5 times 2 plus 2 times 5. We have -5 times 1 plus 2 times 3. And then, of course, when we simplify this, 6 minus 5 is 1, 3 minus 3 is 0. -10 plus 10 is 0, and -5 plus 6 is 1. So both of these together prove that A and B are inverses of each other. All right, so let's see if we stop here. Yeah, I think we'll go ahead and stop and continue on the next video.